I want to talk about what happens when your subject matter, before students come into your class, your subject matter is already has this negativity towards it, which mathematics, you can arguably say that does have this stigma attached to it. So what I have here is a problem that does not look at face value like a mathematics problem, but this will actually get into the idea of decision trees. Like, if I make this decision, I branch out into these decisions. And what that allows you to do is get into talking about counting things. So this is actually the beginning of something in discrete mathematics where you talk about these really complicated things of counting where the students are discovering these things. And this is how it starts. It starts with something that doesn't necessarily look like what you would expect. But through the investigations, it ends up coming up. So I want you to kind of picture this idea here, where students are responsible for the work they do. They are engaged with the material. They also love the class, which is totally what they say about math. So, right. But the idea here is that these fall into this category called active learning, where you are doing something other than exactly just lecturing. The point is for more of the focus to come off of you and actually go to the students, to the point where they'll sometimes go like, he doesn't do anything. He just gives worksheets and we just do all the work. You know? And this happens often, but to me it sounds like they are feeling that the work is on them, which it should be. Right. So I'm going to talk about only this one, but these are very similar to each other. Chemistry is very deep within the bottom one. So, I got it. Oh.
Did it freeze?
No.
Okay. Oh, okay. We're back in business. All right. So I want to describe what IBL is. So it's inquiry-based learning, and you essentially pose a question like I had at the very beginning, and you take this information and you try to answer it. And the thing is that you don't give all the details. You don't make sure that it's all contained in this little box so that they have freedom to be creative with their answers. In fact, you want them to be, because sometimes they come up with actually interesting things that lead into very good questions. And they've actually led into other areas other than what the class is focused in, but they're investigating, and that's really the point. So we want to make sure that they are engaged with the material in the way that they are going through these things. If they get a right answer, there's no really right answer. It's whatever they have in the context of what they're trying to come up with. Because when I present that first problem, they'll start coming up with, well, what if I throw the torch and crossed it? And then it's like, well, if you're allowed to do that, what's your answer? So you come up with different answers if you allow different things to happen. So these are just rephrasing what the question's asking, but you can always change your answer based on what you're doing. So we are going to build these skills that they're going to enact into what they do. And the point is that they will, it'll start out slow, and that's okay because they're really building an intuition. And as they build this intuition, it'll pick up faster and faster. So you'll see in the very beginning of something that's really just IBL, it's very slow, 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 and then really accelerates quickly because they start going like, oh, I know how this goes, I have an intuition for this is where we're going with this. And they, sometimes I'll just walk into the classroom and they'll already be working on stuff. It's like, I'm gonna go get a drink of water. So I try, it's actually, it is a teaching strategy to just walk out of the room because you don't want them to ask you, well, what's the answer? So I will sometimes you'll see me in the hallway, like during class, I'll just walk out of the room, a minute later I'll call them right back in, and then they start having questions. This is very typical because you want to be, have them engage with each other because a lot of this is very group work. Now, you want to have these items within it so that when you have this question, they have a focus, They make some guess based on what they've structured from this problem. They run experiments, they analyze it, they see what's happened, and they form conclusions based on those things. And then the last step is communication. And these all seem like very good things that you want them to be able to do. So a lot of this already is enacted within an IBL structure. Now, you don't need to know any of these things. The point is that I can go through in IBL through all these objectives, which are the same objectives that a normal number theory class would go through. So I can do all these in the same amount of time using IBL only. And what I mean by that is I have no exams. None. There's not a single one where they're, oh, we need to do this on our, we need to take home an exam. There's nothing like that. What I do have, though, is these pre-labs, individual. They do this by themselves. Afterwards, they work together on the labs. So the pre-labs will give them all the definitions they need. The labs themselves, that's when they start experimenting. And the final thing is applying their experimentation ideas. So I will hand out, like, here is the conclusions that you were supposed to get. But the thing is that in this class, there are actually problems that you can't solve. And I do that on purpose. It's because I want them to try something and maybe they'll actually get the right answer. That'd be great. I'd like them to tell me first before anyone else. But so there are unsolved problems in this stuff, and I want them to think of, what would I do to answer this thing? Because they are going to be the ones investigating this. I want them to come up with the conjectures. I want them to have ownership of the material. And having a time when you don't know the answer and no one does, well, that never happens in life, right? But that's the point. I want them to have this experience. Like, I want them to try something that no one knows if it can be done. And it's okay that they didn't get the answer. But at the very end, I will share with them, like, this is what were the expectations of the entire material. So they'll have that when they go into the homework. Now, I've done this in mathematician, so apologies. Abstract algebra, linear algebra, number theory, coding theory, combinatorics, biostatistics, and college algebra. So it runs the gamut. I've done it in lower level classes, I've done it in higher level classes. I do these activities for K through 12. That first activity I did for a group of 5th graders at Auburn. They just came on campus and we were like, all right. And we had like little signs and a little bridge, and it was like adorable. So the point is that these things can be restructured for any age. And it's really natural for them to really investigate into these problems. They don't necessarily need to have a huge background. You can really strip down a problem down to its basics. In abstract algebra, I don't go like, here is the giant definition that you're going to be using for the rest of the course. No. I go, here's a shape. How many rotations does it have to land on itself? Does it have any flips to land on itself? That's it. And then I let them go. About week 3, we'll get to the big definition that normally you get day 1. But it gives them a more natural understanding of it. And what happens is that, again, week 1, usually you'd have this, but week 3, we've covered it now. But it picks up, as I said, it goes faster as the course goes on. And I use that to my advantage as I go through this. So the point is that there are a lot of these resources. So these 3 are part of a NSF grant. They made materials for these courses. This is an entire organization built for helping people build IBL into their classrooms. I attended a workshop with them. You can email other faculty. If you look at their sites and you see, oh, they have materials, I'd love to have them. Email them. People are friendly, I promise. You can also, for mathematics, there's this journal that people are just, it's free, it's online, and people just publish their notes into it, and people review them and make sure they're good, and then other people can use them. Or you could ask me. I have a general idea of how IBL works in any structure. So really, you have a lot of resources. So really, what we want to be able to do is take IBL and implement it into really a lot of places, but don't just go like, I'm going to change the entire course. It'd be very dangerous to do that. And what you'd want to do is try something. Try to revamp an activity or something like that. That would be where you would want to start. you want to be able to build into maybe a day, then a week, then maybe half the class. I don't build these things in one day. It takes me months. And I've just been able to do this for a whole course scratch. So it's very difficult, and I expect you guys to have struggles, and that's okay. It's okay to make mistakes. Oh, that's the answer, by the way. Most people at 19.